In this video, I'm going to go over section 10.7. So first, I'm going to talk about, go over again what those different parts were. We had already talked about the tangent segment, and then in the video, I went over the secant segment, which is this whole thing, and the external secant segment, which is the outside. So from now on, when I go over the investigation, I will be referring to these segments as the tangent, the whole for the secant segment, and the outside for the external secant segment. So first, we're going to go over the two chords investigation that you are supposed to do. So I asked you to use vertical angles and inscribed angles to figure out how these two triangles are related. So hopefully you are able to see that angle A and angle D are congruent because they're inscribed angles that intercept the same arc. Same with angle B and C. And then the vertical angles are also congruent. So we can say that triangle AEB is similar to triangle DEC. So using these letters that I gave you for the lengths of the sides, AE and ED are a pair of corresponding sides, so I can make a ratio out of those. And BE and EC are a pair of corresponding sides, so I can make a ratio out of those. Oops. And if I cross multiply, I get A times B equals C times D. So looking back at these parts again, if I multiply the two parts of each chord, those products are going to be equal. So for example, if I take chord AC, it's broken into this piece and this piece. So if I take A times B, that product is going to be equal to the product of the two parts of this other chord, BD, which is C times D. Now let's look at the secant tangent investigation. Here, you were supposed to look at this big triangle right here, so DBE, and this little triangle here, CBE. This one's a little tougher, so we're going to be using this arc right here, BC. Angle D right here intercepts that arc BC, and angle C right there intercepts that arc BC also. Both of those have their vertex on the circle, so they are congruent to each other because they're 1/2 their intercepted arc. Both triangles have angle E in them, and so angle E is going to be congruent to itself. So now we can conclude that triangle BCE is similar to triangle DBE. So when we make our ratio of corresponding sides, we can say that A, segment CE, goes with segment BE, C, and then we can say segment BE from this triangle, so C once again, goes with segment DE from that triangle, which is B. When we cross multiply, we get A times B equals C squared. So using those terms that I talked about earlier, A is the outside, B is the whole secant segment, And C is the tangent, so we have the tangent squared. Finally, we're going to look at the secant case. So in this one, we can see that angle C and angle E are both inscribed angles with the same intercepted arc, BD. So those are going to be congruent to each other. And both of the triangles share angle A, so those are going to be congruent to each other. We can conclude that triangle ADC is similar to triangle ABE. So then we can say that A from this triangle, so AB from this triangle, goes with AD from this triangle, so that's C, and AE from this triangle, which is D, goes with AC from this triangle, which is B. So when we cross multiply, we get A times B equals D times C. Again, using those terms, A is the outside of that top secant segment, and B is the whole thing. And D, or C, is the outside, and D is the whole thing. So we get whole times the outside equals the whole times the outside. Alright, so starting with the two chords one, we say the product of the two pieces of the chords are equal to each other. If I do this example here, I set this up, we have this piece x plus 10 times this piece is x, I'm going to put that outside here, equals this piece, x plus 1, times this piece here, which is x plus 8. Simplifying then by distributing, we get x squared plus 10x equals x squared plus, if we add the inners and the outers, we get 9x plus 8. The x squareds are going to cancel, and then if I subtract 9x over here, I get x equals 8. Now, another example using the same formula would be this problem right here. So notice here they don't give us the whole circle. But what we can assume is, since this is the highest part of the tunnel here, that is a piece of the diameter, because the longest segment is going to go through the center of the circle there. Also, we've got this segment going through the center of the circle that is perpendicular to this chord right here, the 48. So we can conclude that these, since these are perpendicular, that is bisecting the chord. So if I redraw the picture, this here is my 12. And since the chord is bisected, each of these pieces are going to be 24. Now, it's asking me for the radius of the circle. We're going to have to indirectly solve for that radius. We're going to use our formula here. I'm going to call this piece x. So I have 12 times x equals 24 squared. So when I square 24 and divide by 12, I get that x is equal to 48. So this piece right here is 48. By adding these two pieces together, the 12 and the 48, I can conclude that the diameter is 60, and so the radius has to be 30. All right, using our next formula, the secant, that's our whole times the outside equals the whole times the outside. So in this case, we want to be careful because this is the outside and this is the whole. So our whole is actually 9 plus x. So I have x, the outside part, times 9 plus x, the inside part. I want to do the same thing for this piece here. So the whole, the outside part is 4, and the inside part is 4 plus 5, or 9. So when I distribute, I get x squared plus 9x equals 36. That's a quadratic equation, so I need to move everything to one side. That factors to x minus 3, x plus 12. So x could be 3, or x could be negative 12. Well, negative 12 doesn't make sense because this outside piece can't be negative 12. So x has to equal 3. And finally, our last equation would be the whole times the outside equals the tangent squared. So once again, we want to be careful that we're doing whole times the outside and not outside times the inside. In this case, the outside is x. The whole is this entire thing, which is x plus 4. And that's equal to that tangent segment squared. So that's this piece right here. Now this one, we're not going to be able to factor. That's why it's telling us to round to the nearest tenth. So I'm going to simplify that to x equals 2x, or x times 2x plus 4 equals 100. Moving everything to one side, we get 2x squared plus 4x minus 100 equals 0. I'm going to factor out a 2 just to make this easier. And then because we won't be able to factor the rest of this, we're going to have to use the quadratic formula. So quadratic formula is negative b. B is 2. Now it's plus or minus, but if we took negative 2 minus a number, that's going to be a negative number. And again, x can't be a negative number because that length can't be negative. So we're just going to do negative 2 plus the square root of 2 squared minus 4 times a, which is 1, times c, which is negative 50, all over 2 times a, when you put that into your calculator, you get, if you round to the nearest tenth, 6.1 for x.